In this tape, we show a novel video conferencing system that addresses multi-party meetings. The intent is to simulate as much as possible a four-way roundtable meeting by taking advantage of cues and properties that are present in face-to-face meetings.
The traditional method of supporting four-way video conferencing is to partition a single monitor into 4 quadrants, each of which is occupied by one participant. This means that if I'm talking to 3 other people, on one screen I see each of them in addition to myself. One of the problems that results from such a configuration is that the visual cues of gaze and head turning are no longer present. In face-to-face meetings, these cues play an important role in regulating the flow of conversation. Gaze, for example, provides important feedback on which communications are being attended to and is known to play a role in communicating the nature of interpersonal and status relationships.
Conversation analysis. Our approach is to place a camera, monitor, and speaker in the locations that would be otherwise occupied by each of the remote participants.
We've set up 4 rooms, one for each participant. Remote participants are seen through their own set of video equipment. So, for example, in my office, I see the person across from me through this monitor, and they see me through this camera, and I hear them through this speaker. Similarly, for the person to my right, there's a monitor, a camera, and a loudspeaker, and to my left, a camera, monitor, and loudspeaker. Each of the 4 rooms is set up basically in the same way, with this trio of equipment, where the equipment replaces the participants, or the space that those participants would normally hold.
As you can see, although the idea may be good, the packaging can be much improved. No one should be expected to deal with this on their desktop.
To achieve a workable solution, we turned to industrial design. Working together with the Arnott Design Group of Toronto, we explored a number of different design ideas through a series of meetings, drawings, and a few simple models. We took both functional and aesthetic considerations into account. A design was agreed upon, and 3 functional prototypes were constructed. This is one of the 3 working prototypes that we built. It consists of a color LCD monitor, a camera, and a loudspeaker, and comes in a very compact package. It tilts forwards and backwards and has a telescopic feature which enables you to adjust the viewing position and the camera angle. Let's see it in action. What we have are all 3 prototypes on my desk now, and I'm having a round-the-table conversation with 3 colleagues. On my left is Tracy. Hi, Tracy.
Hi, Bill.
And in the center is Abby. She's sitting right across the table from me.
Hi, Bill.
And over to the right is my daughter, Katie, who's joined us to see what we're doing. Hi, Kate.
Hi.
Now, to preserve the notion of around the table, Katie sees Tracy across from her, and Abby sees me across from her. Now, Abby, where's Tracy?
Tracy's over there.
Okay, and Katie?
Katie's over there.
Okay, and where's Abby for you?
She's over here.
Great. Now, you'll notice that the space occupied by each remote participant is very small, and yet they have their distinct location, which means that the sound comes from their own personal space. But furthermore, each person can see where each other person is directing their attention or their gaze. Eye contact can be maintained because of the small angle between the camera and the monitor. And there's enough space on the desk for me to do other work. Therefore, through the use of industrial design, we're able to get an implementation of the concept which is actually testable and usable in a real-world context.
So far, we've been testing the prototypes. The next step is to do some behavioral studies to reveal the differences between this design and current practice.